Okay, let's give you guys some practice now. So find the limit of this thing as x heads towards 0. Remember, I'm expecting you to know these two very important limits by heart. We've already proved this. So I'm expecting you to know these two by heart. Anyway, find the limit of this as x heads towards 0. So press pause and have a go. Okay, so to do this, break this fraction up into two different fractions, one fraction, and then this being the other fraction. So break it up into two different fractions. So when you're trying to find the limit of two functions, so when you're trying to find the limit of one function plus another function, that's the same as you finding the limit of one function and then you finding the limit of the other function, and whatever the two answers are, then you can add them together. That's the same as you doing this. So really we are making use of this limit law here. Okay, so let me explain this limit law. Hang on. So let me explain this limit law here. So here you've got a function, I don't care what it is, let's just say this function f of x. Here you've got another function, let's just say g of x. And here is a combination of the two when you get this plus this. For example, let's say this is a here, and this is 2, and this here is 3. So when you get 2 plus 3, it will jump to here, 5. So the point I'm trying to make here is that, let's say this is a here. This here is f of a. This here is g of a. And then when you get this plus this, it will then jump to here. If you look at b, this is f of b. This is f of this is g of b. And when you get f of b plus g of b, then it will jump to here. So when you're trying to find the limit of this complicated thing here, let's go back to a here. When you're trying to find the limit of this complicated thing here, when you're trying to find the limit of that complicated thing, f of x plus g of x, as x approaches a, so this thing here is saying find the limit of this function as it approaches a. So you're trying to find this point here. Well, that's the same as me taking the limit of the function f of x. So that's the same as me taking the function of f of x as x approaches a, and then on a separate occasion find the limit of g of x, find the limit of g of x as x approaches a, and whatever this limit is, if I add the two together, it will jump to the same place. So what this is saying here is that find the limit of this complicated thing, but rather than finding the limit of this complicated thing, you can just find the limit of f, find the limit of g, find the limit of f, find the limit of g, whatever the two answers are, add them together. It will take you to the same place. That's where this thing here comes from. Anyway, let's go back one step. We are currently here. So you finding the limit of the sum of the two is the same as you finding the limit of one, finding the limit of the other, and whatever the answer is, then just add the two together. Okay, so that will then take us to here. So now looking at this is a constant. We're able to drag it out, and again, let me explain why that is. Let me explain why you're able to drag this 2 out. Hang on. So from here, this is a constant. We can drag the 2 out here, giving us this thing here. Okay, so now we've got one block multiplying with this block, and then add this block here. So let me explain why we're able to drag a constant out of the limit. So hang on. So really we are making use of this limit law here. Anyway, let's say you've got a function f of x, and then here you've got a constant times a function. For example, let's just say this is x squared here, and then 3 x squared. So this 3 here is a bit like this this c here, and then this is whatever function we're talking about. Anyway, let's say we've got a function f of x, and then this function here is c f of x. So when you're trying to find the limit of this new function here, let's just say this is a here. So so you're trying to find the limit of this new function here, rather than finding the limit of this thing here, we can just find the limit of f. So find the limit of f. Once you've got the limit, then you just times it by c. It would take you to the same place. So up here it's saying find the limit of this complicated thing here. But rather than finding the limit of this complicated thing here, you can just find the limit of f of x. And once you've got that limit, then just multiply it by c. It would take you to the same place. So that's why you're able to drag a constant out. So let's go back one step. So we were here. Now you can drag the 2 out because there's a constant. That will then give us this thing here. That will then give us 2 times this thing plus this thing here. So now looking at this, remember we want to get to this point here, sine x over x, take the limit, and we know that this, well, you must know that this equals 1. But here these two are not the same. They have to be the same. These two bubbles have to be heading towards 0 and on par with each other. So for example, if you have something like this, x to the power of 7 over x to the power of 7, as take the limit as x tends to 0, you can actually say this to be 1, because this bubble is heading towards 0, this bubble is heading towards 0, and they're on par with each other. So then you can conclude that this whole thing here equals 1. Well, let's go back to here. I've got to get these two bubbles to be the same. So let's well, you've got a fraction. When you've got a fraction, you can times top and bottom by the same thing. I'm going to multiply top and bottom by 4. So so this is one block at the moment. This is another block. So when you times top and bottom by 4, you're going to get this. You're going to get the old block times 4, and then the denominator times 4. So so now drag, this is a constant here, so drag this out here, so that becomes 8, and then you've got your one block, and then you've got your other block here. And notice that these are heading towards 0, because as x heads towards 0, this bubble will head towards 0, this bubble will head towards 0, and they're on par with each other. So you can conclude that this whole thing here, oh, by the way, looking at this, if this is a 5, then you can't conclude that the limit equals 1, because this one's, even though it's heading towards 0, even though this is heading towards 0, they're not on par with each other. If this is a 5, they're not on par with each other, so you can't conclude that it equals 1. You can only conclude that it equals 1 when they're heading towards 0 and on par with each other. So so luckily this is 4x. They are both heading towards 0, and they're on par with each other. So we can conclude that this whole block here equals 1. So so this equals 1, and this thing here, you must know that it equals 0. So so this is 0. So it's really 8 plus 0. So your final limit is this thing here. If you get a graph plotter and plot the original function, this thing here, and then as x heads towards 0, so you're approaching 0, hang on, you can see that it heads towards 8. There, that's from approaching it from the left hand side. Let's approach it from the right hand side. You can see that it heads towards 8. Now dead on 0 it breaks down. There should be a white circle in here. If you zoom in, there should be a white circle, meaning that it's undefined, dead on 0. But the point of a limit is where it's heading towards. Well, it is heading towards 8, even though dead on 0 it breaks down, but the limit is actually 8. Okay.